This is now the Matlab code that I wrote to simulate all the signal. As I mentioned in earlier part 1 that we have to define some parameter. Here is the line rate. There is a different galvo voltage. You can change this value. This is the trigger duration. How much will be the duration of the trigger? Trigger delay time. You can define this parameter. And these are changeable parameter. What is line per frame and other data. Now one thing is that as you need a clock, so for the clock you need to define the minimum unit. As we see that if you look at the time parameter, we see the de-trigger delay time is the lowest time we can see here. So I took this as a parameter and convert everything in terms of the triggering unit. So time per a line, if I convert the time, so normally t equal to 1 by f, and if we convert in microsecond, then you have to multiply it 1 e to the power 6. Now we are assuming here that the trigger delay with respect to clock is 1. Then I convert every other time with respect to that. I convert the chunk time with respect to that. Everything with respect to that. Now here the simulation that I done is for the 2 consecutive volume, and we'll see that how things goes for 2 consecutive volumes. And frames per volume we set as a 5. So these are the, how can we generate the graph? Generate the slow galvo axis waveform. Here you need, these are the parameter that you need. Let's see what's inside this function. Basically there is another function to generate the galvo voltage. Here is the galvo max minimum, line per frame, all other parameter. So these 2 lines will basically generate the waveform for the galvo. Now as we have to add the cosine function, this is the cosine function I use. So I use the cosine function to smooth out. Similar thing I did for the first axis. So this is the normal waveform. This is the normal waveform, and you can generate in between gaps what will be your waveform. You can generate this kind of things. Now this is the trigger line. I generated the trigger line here. Trigger line basically 1s and 0, bounce up 1s and 0, and add trigger delay. You have to add some trigger delay starting from the frame 1. Then this is the data. I think same code, just you have to take inside the function of the chunk data. What is the gap between 2 volumes? And this is the final result. Let's run the result. Showing something. This is the final result of the frame, 5 frame, and this is the animation. We are showing the 500 point. This is the triggering point. You can see the galvo voltage. This is the slow axis, and this is the fast axis. We run the value from -5 to +5. So you see that as the scanning progress, the red line, that is the fast axis, that's moving fast. So that will move up as it go forward. It will be moved up. Slow axis will remain constant. These are the triggering. We'll see the same trend. That means the red line or the fast axis, the voltage is changing, which will indicate that the galvo mirror is changing, which is eventually changing the laser beam in the tissue, and light is collected from the different point of the tissue. And these things will change after capturing the whole frame. So we have to wait up to 1024 points, because we define that 1024 points equal to one frame, and we have also defined that in between frame there will be gap of one chunk. So one chunk equal to 128 points, because you can see here that the X voltage is smoothing out and the Y voltage is smoothing out for the new position. So this is the transition. Actually, I defined that among 128 points, like the galvo X voltage will come near the next pulse, near the minimum value within the half points. That means 128 divided by 2 equal to 64. You can define that the galvo voltage will decrease from top to up to here, start of the next pulse. This is the next pulse. You see that is smooth, so that there will be no jerk in the galvo. If you don't design like this way using the smooth function, the problem will be that like start of the each frame there will be some jerk. Image will not be good, so you have to use some smoothing function to compensate that, so it will run like this way. So that's the design. One thing is that after finishing for the volume 1, when there will be transition in between two volumes, we will also see like this kind of smoothing trend. I'm not going up to that. Okay, thank you. If you have any question, you can comment below.